Let me give you another example of concavity. So let's look at y equals x to the power 3. Differentiate it once. That would tell you the gradient. So that would be 3x squared. Differentiate it again. That would then give you the concavity. So here the concavity would be 6x. So what that means is if you're standing at, let's say, 2 here, the coordinates would be 2, 8 because it's cubed. And the gradient here would be 12, not to scale. But the concavity here will also be 12. It would be 12 here. So that means it's trying to bend upwards, because if the concavity is bigger than 0, then it's trying to concave up. And you can see that it's trying to, ignoring this side, it is trying to concave upwards. Now let's look at negative, let's say negative, let's look at negative 2. So negative 2 here. Imagine you are standing here. This is you standing here. Your gradient would be 12, because look, you're still going uphill, just like over here, you're going uphill. But then your concavity here is negative 6. So that means you're concaving down. So if you look at this side of the cubic graph, it's trying to concave downwards. Here, it's trying to concave downwards. Up here, if you're standing here, if you ignore the left-hand side, it's trying to concave upwards. It's trying to concave upwards. If you're standing here, it's actually trying to concave downwards. You see, there's a point here where the concavity is 0. So right here, the gradient would be 0. That means it's flat, not drawn to scale. There is no gradient here, and there is no concavity because over here it's trying just to the right of 0. It's trying to concave upwards. Look, it's trying to concave upwards. To the left of 0, it's trying to concave downwards. So here you've got concave down meeting concave up, and the gradient is 0. And the concavity is also 0. So here we call this point here, this is what's called an inflection point. So an inflection point is when concave down meets concave up, and also the second derivative equals 0. That's what's called an inflection point. Okay.